Hello, here's another bonus video for when you're working on the homework in section 5.2, problem number 13. I thought it was a pretty tricky problem, and I wanted to make sure that you guys knew how to do this. So if you don't have to watch this video, if you can just do the problem if you know how, but if you get stuck, this should help explain it because this problem is something really similar to problem number 13. So it's just I'm asking the same question but with a kind of different function. X squared minus 9 is inside of the square root instead of the other function for problem 13 has a square root of 36 minus x squared. So anyways, let's graph this. Take out your calculator and follow along. It's good to practice it on your own calculator, much better than just watching me do it. So we're going to start by graphing this function. So we go to y equals, and we want to graph the square root, y equals the square root of, oh, whoops, that's x squared. The square root of x squared minus 9, right? Yep. So we're just writing y equals the square root of x squared minus 9 because when you're graphing y and f of x pretty much mean the same thing. So, and we want to get it in this special window here. So we hit the window button, change the x min, whatever it was before, just change it to negative 9.4, change the x max to 9.4, and the y min and the y max can be standard there. This is the window that makes it easy to use the trace function because it's going to make it so each time you go to the right, after you press graph and you go here, each time you go to the right when you trace, it's going to go over by 1 pixel, which comes out nicely to 0.2. So I just press trace and I'm pressing the right arrow now. But you see there aren't actually any points here. So it will say x equals 0.8, but just y equals blank, and there's no actual cursor in the middle. So if we keep going a bit more to the right until we get to an actual point, here's the first actual point. So let's see. Now, yeah, you actually get y equals 0 from that. And you can go back and forth, and it's nice that using this friendly window thing, it just goes up by 0.2 every time instead of those awkward decimals that you get most of the time. So if we wanted to find the x-intercepts of the graph, that's a point on the x-axis. We've got one right here. 3, 0 is one of the x-intercepts. So we can write it as 3, 0 represents that point there. And then if we also trace all the way to the other side, oh, went a little too far. Right here, that's a point where y is 0, so that means that's another one. So we have 3, 0 and negative 3, 0 as answers to that. But if we wanted to write this in function, oh, I'm writing that in the wrong spot. Whoops. If we want to write the answer in function notation, that's not what this is here. That would mean write f of something equals something. So that should look like f of a number equals another number. So the first one is f of 3 because that's an x coordinate that we write that as the input into the function equals 0, like so. And the other one is right here, f of negative 3 is 0. And that is really the answer to this question. Okay, the next question says, why are there no points with x greater than negative 3 and less than 3? So yeah, that's what we saw before. There's no points on the graph when you go to the right here. And let's think about why that happens. If, I don't know, you plug in a number like negative 1 into x, why do you get no y coordinate out? Let's see why that happens with the definition of the function. So if you do f of, let's say, -1, the definition of this function is that should be the square root of that input squared, and then that minus 9 all inside the square root. But we're plugging in x equals -1, so this is going to be -1 here. And that gives you a result of the square root of -1 squared is 1, so you get 1 minus 9, or the square root of -8. But this is imaginary. You can write it as the imaginary unit times the square root of 8, but it's not a real number. So it doesn't actually show up on the x-axis because the x-axis only has real numbers on it. So let's see if we can come up with what is it about x values between -3 and 3. Well, we know what's going to happen when we say we do f of -3, we know we're going to get 0, for example. Let's see why that is. Just using the formula this time, looking at it from a different perspective than from the graph. You're going to get -3 squared minus 9, and -3 squared is 9, so 9 minus 9 gives you the square root of 0, which is just 0. And so if you plug in 3 or something greater than 3, or -3 or something less than -3, you're plugging in to the square root, you end up taking a square root of 0, which is you're allowed to do. The square roots of negative numbers make it undefined. So to summarize this explanation, these values of x between -3 and 3, those values of x, or any value of x in there, makes f of x into the square root of a negative number, which is imaginary. And that's why you don't actually get any points on the graph there. All right, tricky problem. Good luck with number 13. It's kind of the same idea.